Hey folks, this video is about logarithms and their derivatives. So here are some goals I have for you for after you watch the video and read the corresponding part of the textbook. So what is a logarithm? Let's start with an example. A function called the common log, sometimes it's written log, L-O-G. More correctly, it's written as log base 10 of x. And when we're talking about this type of log, we're very roughly talking about the number of digits in x. And well, not really the number of digits, just less than the number of digits in x. But here are some examples of some numbers and their logarithms, their common logarithms. And this is not a super useful definition. So more correctly, we say that log base 10 of x is equal to y exactly when 10 to the power of y equals x. So to ask what's the log of x, we're asking 10 to what power equals x? Well, 10 to the 1 is equal to 10. So we would say log base 10 is 1. Log base 10 of 10 is 1. Log of 100 is 2. Well, that's because 10 squared is 100. And this works for numbers smaller than 1 also. Log of 0.1 is minus 1, since we could write 10 to the minus 1 equals 0.1. So what is a log? What is a logarithm? It's the inverse function of an exponential. Just like we could have an exponential with any base, we can have a log with any base. Another important logarithm, and this is maybe the one we'll use the most in this class, is called the natural log. This is the log base e, or ln of x. And we say ln of x equals y exactly when e to the y equals x. So to ask what's the natural log of a number x is to ask e to what power gives us x. And what is e? We don't have to be afraid of it. E is just a number. It's about 2.7. There is a definition for it, but we don't have to worry too much about it. So what's the derivative of a logarithm? Well, we'll do this very generally. We'll talk about any base for a logarithm. And remember, log base a of x, to say that equals y, means that a to the y equals x. So in general, to ask what's the log base a of x, we're asking a to what power gives us x. So what's the derivative shortcut for that logarithm? We'll do something similar to what we did for inverse trig functions. If y is equal to log base a of x, then a to the y is equal to x. And we know how to take the derivative of an exponential. We can use implicit differentiation to take the derivative of both sides. The right side, hopefully very easy. The left side, we use our exponential rule, not the power rule, the exponential rule, because our variable y is in the exponent. But remember, y is a function of x, so we need to use the chain rule as well. Y is sort of the inside function to the outside function of the exponential. So we multiply by the derivative of y, that is dy dx. And we can solve for dy dx, 1 over a to the y times ln of a. But remember, a to the y was x. So we can replace that with x and say the derivative of log base a of x is 1 over x times ln of a. So for the two examples we saw, log of x, that is the common log base 10. The derivative is 1 over x times ln of 10. ln of 10 is a number that's about 2.3. And the derivative of ln of x is simply 1 over x. Why is that? Well, ln of e, to find that is to ask e to what power gives us e, and of course e to the 1 gives us e. ln of e is just 1. So let's quickly go through a few examples. Let's compute a few derivatives. So the first, log of this value, and here when I write log I mean the common log base 10. Remember the derivative rule we just saw is it's 1 over whatever's on the inside times ln of 10, so we'll write that. But then the chain rule says we should also multiply by the derivative of that inside function. The next, again, this is a chain rule question. We'll use the power rule for the outside function. The 2 will come down to the front. We get a new exponent of 1. We don't need to write that. And then we multiply by the derivative of the inside. The derivative of the inside is just 1 over x. That's the derivative of ln of x. And one last one. How about ln of e to the x? Well, we'll use the chain rule one last time. That's 1 over the inside, 1 over e to the x, times the derivative of the inside, also e to the x. But then our e to the x's will cancel to give us just 1. Well, that's right. Ln of e to the x is just x. To say these are inverse functions mean they cancel each other out. Another way to see that, ln of e to the x is asking what power of e will give us e to the x? Well, the answer is x. And of course the derivative of x is just 1. So we'll see some more examples in class.